Newton's first law. It states that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force. In this case, object A is in rest. Then an external force is applied to it and the object starts to move. Now we're going to see a real-life example.
The Newton's second law is stated as the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. So this means that when the acceleration of a body that is acting is directly proportional to the force, and it's also proportional to the mass of the body. So when the force is acting on an object increases, the acceleration increases. But if the mass of the body increases, so if it's more mass, the acceleration decreases. Now I'm gonna show you a little example of this. What I'm going to be doing, I'm going to be pushing this chair and then a car. So I push it, and since it doesn't have that much mass, it has more acceleration. Okay, so finishing up with the Newton's second law. For a bigger example, I tried to push a car, obviously with more mass, and so since it has more mass, I need to put more force required, and the acceleration decreases. As you can see, I'm doing it, and I look so sexy doing it. Look at me. It was difficult, I'm not gonna lie, and then I gave up there, but I did it. And thank you so much. And we're passing on to the Newton's third law. See you!
Newton's third law. Presented in 1686, Newton's third law states that for every action in nature there is an equal and opposite reaction. In other words, if object A exerts a force on object B, then object B will exert a force on object A. An example, if you're in a boat and you decide to dive, you exert a force on the boat, and in return the boat does the same to you. Here's the action, and here's the equal and opposite reaction. Another example. Here the cat exerted a force on the chair, and the chair did the same.